Alright folks, so today we're going to be working on breadboard number 2, which is pretty much the same as last time, where we actually calculate all this stuff using those tables, but now we're just going to measure them in TinkerCAD. So we're going to build them, and we're going to measure them in TinkerCAD. We'll do this again in real life, but right now we're just going to do like a virtual simulation. And you'll need TinkerCAD to do that. By the way, if I go a little too fast, feel free to pause and rewind this video as needed. So I just searched TinkerCAD, I clicked here, and let me log myself out actually. Let's see. I'm gonna go new design. So for you, it's on the left side, I do believe. This is my teacher view. I think on the left side, make sure you're choosing the one that says electronics or circuits or something like that. So this one says circuits for me. So maybe it says circuits for you. And then that'll give you this new circuit field. First thing we're going to need is a breadboard. So I just grabbed it and dragged it right out. And how breadboards work is, you see when I touch this row, all these light up. That means electricity will travel anywhere. If I plug something here and here, they are connected. But they're not connected to this one. Okay, and they're not connected to the ones next to it. They're only connected to these 5 pins, and that's it. So if I want to connect, I can connect up to 5 different things here together, but that's it. And then these rows go this way, though. They go this way. Okay, and anything you plug in here will be connected to anything else plugged in here. All right, so let's do those 3 resistors. Let's grab one here. And by the way, do not plug them in this way. This is plugged into itself. Remember how they run this way? I don't want it to plug into itself. So go ahead and click it, and let's rotate it. I think we could do that right here. Rotate. There we go. That's how you want it aligned like that. So let's go ahead and take 3 resistors. I'll do another one here and another one. And let's rotate them all. And you can connect them together like this. Technically, they're in series. The electricity flows in here, goes here, goes here, goes in here, comes out here. But if you want to use wires, you can as well. If you want to separate them just a little bit. Like this, that works the same. And then we can connect them like this with the wires. Like that. And let's do that over here. So I skipped one here, a hole, and here I just did them directly next to each other. So electricity is going to go in here, come out, go here, come here, come here, go through here, come here. So they're in series. Okay, these are in series. Electricity has to go through each one. There's no other way to go. Oops. Let me push escape if you do that. Let's change the resistance. I do believe that this was, get rid of the K. We're not in kilo ohms. It's 1 ohm. And then this one is, let's go back to ohms. And this one's 2 ohms. And this one is, I don't know why I can't see that one. There we go. And this one is, I think, 3 ohms. I think so. Let's just double check that. 1, 2, and 3. Yeah. Okay. That wasn't hard to remember. So let's double check. 1 ohm, 2 ohms, 3 ohms. Perfect. Now we need power. You can use a 9-volt battery, but this has 24 volts. So let's find a variable power supply. So I'm just going to type in power supply. Power supply. And here's one that looks like one we have in class. Look at it. I have a USB. But that's 5 volts, remember? So this one we can adjust. So just go ahead and select it and say voltage is 24 volts. By the way, current, this is the maximum current it can do. So go ahead and put 10 amps or whatever, but that doesn't mean 10 amps is going to come out. 5 looks like it's the max. So I guess we'll just say 5. I see 5 is the max here. So we got 24 volts, 5. Perfect. Okay. Now, we need positive. Now, we could run the positive right here and the negative right here, but let's do it the way, breadboards were meant to be. So we'll go here. I'm clicking, click to make turns. There we go. So that's red. You can always adjust these little knobs right here to make this look a little nicer. And let's do the negative. I think it looks nice when I do it like this. There we go. And like I said, you can always make these look nicer if you want to. Don't worry about that. So this is all negative, and this row is all positive. So let's go ahead and let's go positive to this one. Well, is positive connected to the what resistor is this? Let's see. Come on. This is the 1 ohm resistor. And the 1 ohm resistor is connected to the negative technically. I don't know if you can see that. Let me zoom in here. The 1 ohm is connected to the negative. The 3 ohm is connected to the positive. So technically, if we want to do this right, it won't really affect the numbers too much, I don't believe, but we'll just do it right. Negative goes to that one, and the positive right here, and I can grab any of these. These are all positive, right? They lead to this. And the positive goes to this row, and it connects here. And the negative connects here, so positive flows in here, comes through here, goes through here, comes through here, and comes back, and makes a circle. It's not as perfect circle like you see in the picture, but it's still a circle, because I'll follow it one more time. Positive, positive, goes to resistor, goes through here, has nowhere to go, has to go here, goes here, it goes up here, it's trying to find its way out, it goes through here, tries to find its way out, finds this wire, goes to the negative, and we're done. It comes back to the positive and repeats. So it's a circle. Now we need a voltmeter. So let's go voltmeter. Here's a this is a multimeter, even better. So this one does everything. So in this problem, it says to measure only the, let me zoom out so you can read this. The voltage dropped on each one, and it says also measure the total current flowing out of the battery. Okay, so let's do that. We need to make sure this is on voltage V. And on voltage, you're going to love voltage. You just literally touch it on each side of the resistor. We can touch it here, here, here. It doesn't matter. So I've touched it on this side and this side. That's one. Let's do another one. Let's do this one here. And we're going to go here, and here, and here, and here. And we need another one. See how easy voltage is? If you're in voltage, you just literally touch it on each side of the resistor. One here, and one here. And if I push start simulation, you'll see that we have 24 volts. It's only 4 amps because that's all if you do Ohm's law, that's what it should be. You can see your old work. And Kirchhoff's voltage law, 4 plus 8 plus 12 equals the 24 volts. 12 plus 8 plus 4 equals 24 volts. So this is working perfect, but we're missing the main current. And here's the only tricky one. If I'm measuring amps, I can't switch it right now. Oh, because I don't know why I can't switch it. We have to do it here. So when you click this, open the window and say amperage. There we go. I thought you could just click the A. Do not do this. Oh, what's the current? And just connect it somewhere. Do not do that. You have to disconnect something. So let's disconnect. Here's the negative. We'll do the negative. Let's disconnect the negative. It doesn't really matter where. So we'll disconnect the negative, and I'll move this here. And the negative goes to the negative, like that. But it goes in this machine, and it measures how fast it's flowing in here, then put it back to here. It doesn't turn it into a positive. It doesn't. This is still a negative wire. It's just the negative wire needs to go to the negative. If you have it backwards, no big deal. Honestly, if you put it over here and you did it backwards, it would just read negative, and you could just ignore that. Just ignore the negative. So let's go ahead and push play. Should be 4 amps. We already knew that because this machine actually tells us the total amps anyway. So it already said 4 amps. That's what's cool about this machine. We actually have these in class. But that's it, 4 amps. Isn't that cool? So that's what you do for each one. Make sure make sure the resistors are in series. Make sure that you put the right resistance for each one, and then wire it up in a circle back to the power supply. And you should check Kirchhoff's voltage law and make sure that it's right. Does all the voltages on all these resistors in series add up to 24 volts? And that's it, folks. Screenshot. How do you screenshot this? Click the magnifying glass at the bottom and type in snipping tool on your computer. I don't know. You have to look up on how to do this in Chromebook. If you're doing this on a Chromebook, look it up on the internet, how to take a screenshot. I'm going to click snipping tool. I just did a search for it. And what happens is this pops up right here. Do you guys see this little thing? It popped up. Click New, and then just go ahead and drag over all of this like that. As long as I can see all of this, we're good. You can, oh, where's my mouse? The mouse is here. I don't know if you can see it, but you can write, your name on it to prove it's your work. And then here you can click copy. You can save it on your computer and insert it, but you can say copy and then go to your work. Let's say this is your work here and you want to insert your work. You can click paste. You see? And it puts it right in there. It's pretty cool. So that's it.